Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Please try to subscribe and share to your colleagues. Okay. Now we want to look at the solution to differential equation. When you say solution to differential equation, it simply means that when we get a function, let's say y of f, y equals f at x, that when you substitute that function into the differential equation and satisfy it, then you can say that that differential or that function is a solution to that differential equation. So let's look at an example. Verify whether the given function is a solution to the differential equation y equals sine x, y prime prime plus y equals 0. So what you are saying is that this is a function, this is a differential equation. So you want to see if I substitute this function into this, I'll get 0. You understand? But this one is y, this is y prime prime. So it means that this y, wherever I see this y, I'll just replace by sine x. But the y prime prime means that I have to differentiate the y twice. So first, let's differentiate sine. So the first one will be y prime. That will give us what? Cos x. Is that okay? Then we differentiate it second time. That will give us negative sine x. Because when you differentiate cos x, you get negative sine x. And after getting this, let's substitute these two into this. So the y prime prime into this, then the y into where this y is. When I do that, I'm going to have y prime prime is now negative sine x plus y is sine x. And this will give us 0. So therefore, we are saying that this function y equals sine x is solution to the differential equation. I hope you understand that. So when they give it to you, you look at the differential equation, the number of times that it has been differentiated, then you differentiate the function according to that. Then you come and substitute it there. When it gives you exactly what they want here, let's say this is the left side, and when it gives you the right side, then you can say that it's what a differential equation. When it doesn't happen that way, then it's what? You can say it's a solution, you can say it's a solution. When it doesn't happen that way, then it's not what? A solution. Is that okay? Now let's look at another example. Okay, so now let's verify this one. Whether this function y equals e to the power x cos x is a solution to this differential equation. So first thing, we have y here. That one is easy. You just replace the whole of this one here. But when it gets to this side, you have to differentiate this one 2 times. And when it gets to this side, you have to differentiate this one 3 times. So let's start. So y prime, so I'm going to differentiate it first time. Now this is e to the power x, this is cos x. So this one is what? A product rule. So if I want to differentiate it, first I'll hold e to the power x and I'll differentiate cos x. That gives me negative sine x. Plus, then I'm going to hold this, then I'll differentiate e to the power x. It's an exponential function. So if we differentiate e to the power x, to give you the same e to the power x. So I have e to the power x cos x. This is the first differential. Then you differentiate it again. You are doing that because of this, okay? So I'll have this one to the same thing, product we call e to the power x sine x. 2 transcendental function multiplying, and we are differentiating with respect to x. So I'm going to have, there's negative here, so let me maintain the negative outside. So if I hold this e to the power x, then I differentiate sine x, I'll get cos x. Plus, I hold sine x, differentiate e to the power x, I'll get e to the power x sine x. Okay, remember the negative is affecting it. Then you come to this side, you hold e to the power x and differentiate cos x. So now if I differentiate cos x, I'm going to have negative sine x. So I'm going to have negative e to the power x sine x. Then I'm going to hold this and I'll differentiate e to the power x. That will give me e to the power x cos x. Remember, when you differentiate e to the power x, you have the same e to the power x. So this is the second way. So I can decide to expand this one. So So let me multiply through by the negative. So y prime prime, I'm going to have negative e to the power x cos x minus e to the power x sine x minus e to the power x sine x plus e to the power x cos x. Is that okay? If you can group like terms, you group them. So let's see. Negative e to the power x cos x, and this is positive e to the power x cos x. So this will go with this one, so that we have y prime prime to be equals to this and that are the same. So negative 2 e to the power x sine x. I hope you understand how I've done the differentiation. But this is the advanced way of doing the calculus. So please, if your calculus is weak, I'll urge you to revise. Okay. Now let's move on to the y prime prime because of this one. So move to y prime prime. So you are going to differentiate this one. Already, let me maintain my negative out. So if I'm to differentiate this one, I'm going to have e to the power x cos x plus e to the power x sine x. It's just a product rule. So I hold this, then I differentiate this, and I hold this, then I will differentiate this. That's all. So when I multiply to have y prime 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 equals negative 2 to the power x cos x plus e to the power x sine x. So sorry, the negative will be here. So negative 2 like this. So what you are going to do is that you are just going to substitute the y prime prime, the y prime prime, then the y into this equation. So this is what you are going to do. Look here, I'm writing it up here. So y prime prime, we have this, which is negative 2 e to the power x cos x minus 2 e to the power x sine x. Our final answer, you have to get 0. If you don't get 0, then it's not a solution. Is that okay? We are trying to verify whether it's a solution or not. Then we move to this one. That's negative already here. Now y prime prime, what do we get for y prime prime? We had negative 2 e to the power x sine x. Then we move to the last one, plus 2 bracket open y. What is our y? Our y was giving us e to the power x cos x. Okay, so let's see whether this one will give us 0. So if I multiply this one, I'm going to have positive 2 e to the power x sine x. And this one too will be negative. So this and that will cancel. Can you see that? This and that. So negative will be positive. And this will be opposite. And also looking at this one, negative 2 e to the power x cos x, and this positive 2 e to the power x cos x. So this will also go with this, and so finally we get 0. So we conclude that y equals e to the power x cos x is solution to this differential equation because it's satisfied. When we substitute it there, it's satisfied. Remember to differentiate the thing. If you don't differentiate it well, you will not get it correct. Is that okay? Now let's look at last example under this. So now let's look at the last example. We have y equals ln x here. Now we want to see whether this one will be solution to this differential equation. So let's see. X multiplying y to the power 4. This is not even a power. Remember I told you that. This means that you are differentiating this one 4 times. I don't write yiv, no. Then plus 3y prime prime prime. That means you have to differentiate it 3 times. So you differentiate this particular thing 4 times, and you differentiate it 3 times. Okay. So let's start with the differentiation. First, you have to identify this function. It's called a logarithmic function. So for a logarithmic function, if you want to differentiate, you have to know the properties that they use to differentiate. Okay, so we have y equals ln x. Y equals ln x. So let's see. Let's differentiate it for the first time. If you differentiate ln x, what do you get? You have 1 over x. Is that okay? Anytime you differentiate ln x is 1 over x. What you are doing is that we differentiate the x, that will give you 1 over the original function, which is x. Then we're going to differentiate it second time, so y prime prime, that will give us negative 1 over x squared. How did we get this? This 1 over x is the same as x to the power negative 1, so I want to differentiate the negative 1, x will come here, then you subtract like this. And remember, this one can also be written as negative 1 over x squared. It's the same thing, right? Good. So now, let's move to the third one. Y prime prime prime. We are going to have 1 over x cube. Sorry, here will be 2. We have 2 over x cube. Let's see. So negative 1 over x squared can also be written as negative x to the power negative 2 like this. But when I send this one top, that's how it becomes. So looking at this one, this multiplying it, that will give us positive 2x to the power what? Negative 3, because we subtract 1 from it, that gives you negative 3. So that gives you 2 over x to the power 3. So that is correct. Then let's look at the last one. Y. So that's fourth derivative. So for the fourth derivative, you are going to have negative 6 over x to the power 4. So this one, you just have to use the same procedure that I used. That's what you're going to use to get this one. Now looking at this, you want to do the substitution here, whether you get the 0. So this is x, so I'll maintain my x, multiplying by y of fourth derivative, that will be negative 6 over x power 4 plus 3 multiplied by y. Where's our y? Y prime prime prime. So y prime prime prime, we have 2 here. That is 2 over x cube. Okay, so now let's look at this one. This times this will give us negative 6x over x power 4 plus 6 over x power 3. So we see that one of these will go with this. That will give us negative 6 over x cube plus 6 over x cube. Okay, so this is what we have now. And this will give us what? 0. And it satisfies that. So we say that the function is a solution to that what? Differential equation. Please try to practice. Try to what? Practice. When you practice them, you can solve more examples. So please, hope you have understood what a solution to a differential equation is. Please try to subscribe my YouTube channel and share to your friend. Thank you.